Hello everyone, welcome to RC Chemistry. Now I am going to explain the aromaticity of different compounds. First, the compounds are classified into 4 different types, which is aromatic, non-aromatic, anti-aromatic, as well as homoaromatic in nature. So first we have to know what are the different kinds of conditions to be an aromatic or non-aromatic, anti-aromatic or homoaromatic. First, there are 4 certain conditions which are required for a compound to be an aromatic in nature. First, the compound should contain ring and it should be in planar with sp2 hybridization. Next, the ring should be in the conjugation, as well as it should follow Huckel's rule, which is 4n plus 2 pi electrons. For example, n total electrons will be 2, 6, 10, etc. These will be pi electrons. So in order to identify if we count the number of bonds in a compound, if we get odd number of pi bonds, then it can be there will be a chance that a molecule can be an aromatic. Next, non-aromatic. If any of the first 3 rules fails, then it can be non-aromatic in nature. So this is the basic requirement for a compound to be an non-aromatic in nature. Next, anti-aromatic. So again, it should contain ring and it should be a planar with sp2 hybridization. Next, it should contain conjugation. Here the compound is following 4n rule. 4n rule. In other way, we can say that the whole 4 table will comes under this anti-aromatic compound. If we check the stability of these compounds, aromatic compound is more stable than homoaromatic, than non-aromatic, than anti-aromatic compounds. Later we can discuss the homoaromatic case. First, we are going to check this aromaticity in different types of compounds, such as the main important compounds are, we can see aromaticity in different compounds such as annulenes, azulines, fulvalene and calcenes. And then we can check the aromatic character, and then we can check the aromatic character in 2 different types of compounds, which are benzenoid compounds as well as non-benzenoid compounds. The ring which contains the benzene nucleus is said to be benzenoid compounds, whereas the compounds which do not consist the benzene nucleus is considered as non-benzenoid compounds. And then finally we can check Craig's rule, and then quasi-aromatic compounds, and then homoaromatic compounds. So if we clearly understand this concept, this is far enough to solve the problems on aromaticity. So in this video I am going to explain you about the annulenes. Annulenes is nothing but the cyclic conjugated compound, compounds without any charges upon it, We can represent the annulene as X annulene. Here X represents the number of carbon atoms. There are different types of annulenes, such as example 4 annulene, 6 annulene, 8 annulene, 10 annulene, 12 annulene, 14 annulene, 16 annulene. we should have a thorough knowledge of each and every aniline which are mentioned here. First, example 1, which is 4-aniline. The 4-aniline, the structure of the 4-aniline will be this one. Here the total number of carbon atoms is 4. That's why it is said to be 4-aniline. It is said to be aniline because it is a cyclic compound, as well as it consists of conjugation within it without any charges. Hence it is known as 4-aniline. We have to check the aromatic character in this particular 4-aniline. So now count the total number of double bonds. Here the total number of double bonds is 2 bonds, which means it consists of 4 pi electrons. 4 pi electrons. It means it is following 4N rule. From this information, we came to know that this compound is anti-aromatic in nature. Next, 6-aniline. The structure of 6-aniline will be like this. We all know that this is a benzene. Now count the total number of pi bonds. There are 3 pi bonds. 3 pi bonds. Total number of pi electrons is 2 plus 2, 4, 4 plus 2, 6 pi electrons. That means it is following 4n plus 2 pi electron rule. Are you getting my point? Now, as we know that the total number of the pi bonds is 3, which is an odd number. From this conclusion, we can say that the benzene, which is an 6-aniline, shows aromatic character. Next, 8-aniline. 8-aniline. The structure of the 8-aniline is like this. In other words, we can say that this is a octatetraene. It consists of 8 carbon atoms and 4 double bonds, so that it is known as octatetraene. Okay, so from this structure we can count the total number of pi bonds. 1, 2, 3, 4. Total number of pi bonds is 4. From this structure, it contains 4 pi bonds, which means 1, 2, 3, 4, 5, 6, 7, 8. Total 8 pi electrons, which follows 4N rule. According to the 4N rule, this molecule must be anti-aromatic in nature. Anti-aromatic in nature. Whenever this octatetraene molecule contains plenarity, it should possess an anti-aromatic character. But this molecule cannot be in the planar. It loses its planarity. It loses its planarity. And it turns to tub-shaped structure. And then it gives the structure like this. So it is in the form of a tub, so it is named as tub-shaped structure. And if we consider the aromaticity of this molecule, it comes out to be non-aromatic, because as it loses its plenarity. There is no plenarity in this molecule, hence this molecule is said to be non-aromatic in nature. Next. Now, let's come to another one, which is 10-aniline. 10-aniline. The structure of the 10-aniline is, first of all, count the total number of pi bonds. 1, 2, 3, 4, 5. 5 pi bonds, which gives us 10 pi electrons. So, as it contains 10 electrons, we think that it is an aromatic character. But if we see at the fused positions, the 2 hydrogens are present like this. These 2 hydrogens repel with each other, creating steric crowding, which increases the steric repulsion at this center, which disturbs the whole plenarity in the molecule. As a result, it loses its plenarity and results in the formation of non-aromatic compound. Now try yourself. Try yourself. Example 1. This is a 12 aniline. This is 14 aniline. Next, this is an 16 aniline. So try these questions for yourself. If you get any doubts, please let me know in the comments. Okay, thank you. And if you like this video, please like, share and subscribe. Thank you.